Class 9 students. Today I'll start exercise 2.4. Now, exercise 2.4, question number 1. Just you listen the question. Determine which of the following polynomials has x plus 1 a factor. Now, if x plus 1 is a factor of this, then if 0 of x plus 1, if you put here, then it become px becomes 0. Means actually when x plus 1 or x plus a will be a factor of px. Suppose px is a polynomial and check whether x plus 1 or x minus 1 is a factor of px or not. If pa equals 0, then x minus a is a factor of px. Means in place of x, if you put a, then it becomes pa, and pa becomes 0, then x minus a will be factor of px. Similarly here also, px equal given x cube plus x square plus x plus 1, and check whether x plus 1 is a factor of this or not. Now find 0 of x plus 1. 0 of x plus 1 equal minus 1. Why? Because x plus 1 equals 0, so x equal minus 1. So 0 of x plus 1 equal minus 1. Now in place of x equal, you got minus 1. So in place of x here, put minus 1. P minus 1, minus 1 cube, minus 1 square, minus 1 plus 1. Minus 1 cube equal minus 1. Minus 1 square equal plus 1. Plus minus minus 1, 1. This is minus 1 only. Now minus 1 plus 1, minus 1 plus 1 cancel. Now it will be what? 0. So since p minus 1 equals 0, so x plus 1 is a factor of px. Now question number 4. Come to the question number 4. Check whether x plus 1 is a factor of this or not. X plus 1 is a factor of px equal x cube minus x square minus bracket 2 plus root 2x plus root 2. Factor or not. First we will find a 0 of the polynomial. X plus 1 equals 0, x equal minus 1. So you can do like this also, but if you write directly, then also correct it is. 0 of x plus 1 is minus 1. So in place of x, put minus 1. P minus 1, minus 1 cube, minus minus 1 square, minus bracket 2 plus root 2, here minus 1 plus root 2. Now minus 1 cube equal minus 1, minus 1 whole square equal plus 1, again minus, so minus 1, minus minus plus, minus and minus 1 plus, so become plus, so 2 plus root 2, 2 plus root 2, and last one root 2. Minus 1 minus 1 minus 2, this is plus 2 plus root 2 plus root 2, plus 2 minus 2 cancel, root 2 plus root 2, 2 root 2, not equal 0. Since it is not equal 0, so x plus 1 is not a factor of the polynomial px. So x plus 1 is not a factor of this, because p minus 1 not equal 0, it becomes 2 root 2, means we got 2 root 2. So x plus 1 is not a factor of the polynomial px. Now come to the question number 2, 3. Question number 2, 3. Use factor theorem to determine whether gx is a factor of px in each of the following cases. Now, this is px and this is gx. Now, asked here, gx is a factor of px or not. So gx will find x minus 3, 0 of x minus 3. 0 of x minus 3 is 3. Why? X minus 3 equals 0, x equals 3. So 0 of x minus 3 is 3. Now P3, in place of x, you put 3. 3 cube minus 4 into 3 square plus 3 plus 6. This is 6. Now 3 cube equal 27. 3 is 9. 9 4 is 36 minus 36. 3 plus 6, 9. 9 plus 27, 36. minus 36 becomes 0. So we can say x plus 1 here, x plus 1 or x minus 3. X minus 3 is a factor of px. Since becomes 0 means p3 equal 0. P3 becomes 0. So you can say x minus 3 is a factor of px. Now see here, p3 equals 0. Therefore, so x minus 3 means gx is a factor of px. Now come to the question number 8. In question number 8, you are asked to find what? This is question number 3. Question number 3. Now in question number 3 given what? Find the value of k if x minus 1 is a factor of px in each of the following cases. Find the value of k if x minus 1 is a factor of px if each of the following cases. Means here x minus 1 is a factor of px given here. Means what? This is factor of px. Now if x minus 1 is a factor of px, so it becomes 0 if you put x equal 1. Why x equal 1? So 0 of x minus 1 is 1. X minus 1 equals 0, x equal 1. So 0 of x minus 1 is 1. So if you put x equal 1 here, then it becomes 0. Because given here x minus 1 is a factor of this. Now px becomes 0 for x equal 1. Px equals 0. Px means what? This one, x square plus x plus k equals 0. So put x equal 1. So 1 square plus 1 plus k equals 0. 1 square plus 1 equal 2. 1, it becomes 1 plus 1 equal 2 plus k equals 0. So to bring to the right hand side, k equal minus 2. The value of k is minus 2. Now again question number 3, given x minus 1 is a factor of px, kx square minus root 2x plus 1. Means given in the question, this is factor of this. If factor of this, then this equals 0 for x equal 1. If you put x equal 1 here, then it becomes 0, means polynomial becomes 0. So put x equal 1, k into 1 square minus root 2 into 1 plus 1 equals 0. So k into 1 square equal k root 2 plus 1. Now the minus root 2 bring to the right hand side become plus 1 bring to the right hand side minus 1. So k equal root 2 minus 1. Therefore value of k equal root 2 minus 1. Now come to the question number 4. X minus 1 is a factor of px. Kx square, px equal what? Kx square minus thrice x plus k. Given in the question x minus 1 is a factor. So it becomes 0. Factor given, so polynomial becomes 0. So it becomes 0 for x equal 1. Because 0 of x minus 1 is 1. Now put the value of x here. Value of x equal 1. Put k into 1 square minus 3 into 1 plus k. K plus k equal, this is k into 1 square means k. Minus 3 into 1 equal 3 plus k. K plus k equal twice k. Twice k. 3 bring to the right hand side positive. So twice k equal 3. So k equal 3 by 2. 2 bring to the right hand side becomes divide. So k equal 3 by 2. For k equal 3 by 2, the x minus 1 is a factor of px equal kx square minus thrice x plus k.